You've probably heard the name SpaceX in the news. Rockets landing themselves, satellites providing internet, plans to go to Mars. But what exactly is this company? Who runs it, and what do they actually do? Today we're breaking it down simply. What SpaceX is, how their reusable rockets work, how they make money, and whether Mars is really happening. By the end, you'll understand why everyone's talking about them. So let's start with the most basic question. What is SpaceX? SpaceX is a private aerospace company that designs, manufactures, and launches rockets and spacecraft. Elon Musk founded it back in 2002, and it's headquartered in California, with a major launch facility in Texas called Starbase. About 13,000 people work there, and the company is currently valued at around $800 billion. Now, what makes SpaceX fundamentally different comes down to one word: reusability. Think about how traditional rockets work. You launch once, the rocket falls into the ocean, and you build a completely new one for the next mission. It's like throwing away an entire airplane after a single flight. SpaceX changed that equation. Their rockets fly back, land vertically, and get prepared to fly again. One of their Falcon 9 boosters has actually flown 23 times. Instead of spending $400 million on a new rocket for every launch, they can fly for $67 million. When you make something 6 times cheaper, you don't just improve an industry, you transform it completely. Just to put this in perspective, in 2024 alone, SpaceX launched 138 times. That's more than every other country on Earth combined. They haven't just entered the space industry, they've redefined what's possible. Now, who's behind all this? Elon Musk owns approximately 42% of SpaceX and controls about 79% of voting rights. As of January 2026, he's the wealthiest person in history, with a net worth somewhere between $620 billion and $726 billion. Most of that wealth comes from his stakes in 2 companies, Tesla, which is worth $1.5 trillion, and SpaceX itself. The origin story here actually matters because it shows real commitment. Back in 2002, Musk sold PayPal and personally received $180 million. Most people would retire comfortably. Instead, he poured nearly all of it into 2 extremely risky ventures, Tesla and SpaceX. By 2008, both companies were on the verge of bankruptcy. SpaceX had attempted 3 orbital launches, and all 3 had failed catastrophically. They had money for one more attempt. That December 2008 launch saved the company and secured a $1.6 billion NASA contract. When you look back at it, it's almost uncomfortable how close we came to never having SpaceX at all. One more failure, and the entire trajectory of commercial spaceflight would be completely different today. That context makes what they've accomplished since feel even more remarkable. So let's talk about the actual hardware, because this is where SpaceX's philosophy becomes really tangible. The Falcon 9 stands 70 meters tall, about 20 stories. After launching its payload toward space, the first stage booster separates, flips around, reignites its engines, and flies back to land vertically. The precision required here is extraordinary. We're talking about a 25-story cylinder traveling at supersonic speeds, using grid fins to steer through the atmosphere, then performing a landing burn to touch down on a platform that's sometimes a moving barge in the middle of the ocean. They've done this successfully over 250 times now, with a 99.4% success rate across more than 300 launches. This isn't experimental anymore, it's fully operational. The economics speak for themselves. Traditional expendable rockets cost $200 to $400 million per launch. Falcon 9 costs $67 million. That's not incremental improvement. That's fundamental restructuring of how space transportation works. But Falcon 9 isn't the whole story. There's Starship, and this is where ambition becomes truly tangible. Standing 120 meters tall when fully stacked, it's the largest rocket ever constructed. Unlike Falcon 9, which only recovers the first stage, Starship is designed for both stages to be fully reusable. The booster lands, and the upper stage also returns. As of January 2026, Starship has flown 11 test flights. The development has been iterative, 6 successes, 5 failures at various stages. Each flight teaches them something critical. Flight 7 lost the upper stage during ascent. Flight 8 had similar issues. But by Flight 10 in August 2025, they achieved all objectives. Flight 11 in October was essentially flawless. Here's the part that still feels surreal, even after seeing it multiple times. In October 2024, they caught the returning booster with the launch tower's mechanical arms, not landed it on a pad, caught it mid-air. A 70-meter-tall, 200-ton object falling from space, grabbed by 2 massive metal arms, nicknamed Mechazilla. They've now done this 3 times. When you watch the footage, there's this moment of disbelief. The engineering logic is elegant, though. Every kilogram of landing legs you remove is payload you can carry to orbit. If the tower catches the rocket, you don't need heavy landing systems. It's audacious, but it works. Now let's talk about the business side, because understanding how SpaceX makes money explains why they can move so fast. In 2024, SpaceX generated approximately $13.1 billion in revenue. Projections for 2025 suggest around $15.5 billion. This comes from 3 distinct streams, but one dominates everything else. Launch services is the traditional space business. Customers pay SpaceX to deliver satellites to orbit, telecommunications companies, NASA sending cargo and crew to the space station, the military deploying reconnaissance satellites, even universities. At $67 million per launch and 138 missions in 2024, that's roughly $4 to $6 billion annually from launches alone. That's substantial, but it's not the biggest part of their business anymore. The real story is Starlink. SpaceX has deployed approximately 7,000 satellites into low Earth orbit, more than all other operators combined throughout the entire history of spaceflight. These satellites provide high-speed internet directly to users on the ground. If you're in rural Montana, on a cruise ship in the Pacific, or anywhere traditional internet infrastructure doesn't reach, Starlink becomes genuinely transformative. The service delivers 50 to 200 megabits per second speeds with low latency, fast enough for video calls, streaming, and gaming. As of September 2025, Starlink had 8.5 million active subscribers across 140 countries, paying between $50 and $150 monthly. That generates approximately $11.8 billion annually, more than twice what they make from launching other people's satellites. And crucially, it's recurring subscription revenue, which is the most valuable type of income for any business. What makes this particularly strategic is the vertical integration. SpaceX doesn't pay another company to launch Starlink satellites. They launch them themselves at cost. They don't buy satellites from external manufacturers. They build them in-house at their facility in Texas, which is reportedly the largest printed circuit board factory in the United States. This level of control over the supply chain is what allows deployment at a pace nobody else can match. Then there's the third revenue stream, which is still largely potential but enormous: Starship missions. In October 2025, SpaceX announced commercial cargo missions to the Moon, starting in 2028, and Mars beginning in 2030, priced at $100 million per metric ton. If a single Mars mission delivers 100 tons of cargo, that's $10 billion per flight. NASA has already committed $4.05 billion for a lunar lander variant of Starship for the Artemis program. The U.S. military is exploring rapid cargo delivery anywhere on Earth within an hour using Starship. These aren't speculative ideas. They're funded contracts with real timelines. Which brings us to the question everyone asks: is Mars actually realistic? Let me keep this simple. Starship exists and it's flying. 11 test flights have happened and it's getting better each time. The vehicle can reach space, deploy cargo, and come back down. The booster has been caught by the tower 3 times, so the basic technology works. The big challenge left is refueling in space. To get to Mars, Starship needs to fill up after reaching orbit, which means other starships have to dock with it and transfer fuel. SpaceX tested moving fuel around inside one ship in March 2024. Ship-to-ship transfer is planned for 2026. SpaceX says Moon cargo missions start in 2028 and Mars cargo in 2030. Is that realistic? For the Moon, 2028 is tight but possible. NASA needs Starship for their Moon landing, currently scheduled for 2027, though most people expect 2028 or 2029. For Mars, 2030 is technically possible if everything goes well with the fuel transfer tests. But Mars only lines up right every 26 months, so missing one window delays you over 2 years. Here's my honest take. SpaceX has proven they can do things people said were impossible: reusable rockets, catching boosters, thousands of satellites. So when they say Mars cargo in 2030, I believe the rocket will be capable. Whether it happens in 2030 or 2032 depends on testing, regulations, and funding. But the direction is real. As for a Mars city with 1 million people by 2050, that's a much bigger dream. Building a self-sustaining colony needs habitats, life support, food production, water extraction, power, all on a planet with no breathable air. Small research bases by 2050? Maybe. A 1 million-person city? That's a generational project that depends on whether humanity decides it's worth the enormous effort and cost. But here's what matters. If we do decide to go, SpaceX is building the rocket that makes it possible. That's the real contribution. Let me show you what's not speculation, what they've actually done. In 2024, SpaceX launched 138 times. China launched 67 times. SpaceX alone did more than half of all global launches. They've landed boosters over 250 times. They've sent more than 50 people to space. Since 2020, every NASA astronaut launched from the US has flown on SpaceX Dragon. Before SpaceX, after the shuttle retired in 2011, NASA paid Russia $90 million per seat. SpaceX brought that cost down to $55 million and gave America independent access again. Starlink has 7,000 satellites operating right now, more than everyone else combined throughout history. And catching rockets with robot arms, they've done it 3 times. What matters isn't just what they've built, it's that they made the impossible routine. That's the real transformation. So that's SpaceX, a private company that made rockets reusable, provides internet from satellites, and is building the vehicle that could reach Mars. From nearly going bankrupt in 2008 to launching more than all other countries combined today, they've proven that space doesn't have to stay expensive or exclusive to governments. Whether Mars happens in 2030 or 2040, the hardware is real, the progress is measurable, and the direction is clear. If this helped you understand SpaceX better, hit the like button. It tells me these explainer videos are valuable. Subscribe to New Space Review for more space content that breaks down complex topics simply. And I'm genuinely curious. What surprised you most about SpaceX? Their $11.8 billion from Starlink? The robot arms catching rockets? Or the Mars timeline being closer than you thought? Leave a comment. I read all of them, and your questions often shape future videos. Thanks for watching. There are more videos on the screen now about Starship development and other space companies. I'll see you in the next one. Rocket Lab just wrapped up qualification testing for Neutron's fairing. Big milestone. The Archimedes engine? Fired successfully, 164,000 pounds of thrust. On paper, everything looks great. But talk to aerospace engineers off the record, and you'll hear a different story. They're watching this with a mix of admiration and concern. Here's what keeps them up at night. Neutron is rolling 3 completely untested technologies into one rocket. Brand new methane engine. Never been done before fairing design. First flight reusability. SpaceX took a decade to get Merlin reliable. Blue Origin's been wrestling with BE-4 for over 10 years, and it's still giving them trouble. So the question everyone's asking quietly, is Rocket Lab about to pull off something incredible? Or are they setting themselves up for years of painful lessons?
Let me be clear about something first. What Rocket Lab's accomplished so far is genuinely impressive. The Archimedes engine isn't some incremental upgrade. It's a full-flow staged combustion methane engine, same class as Raptor and BE-4. Test firings looked good, solid thrust numbers, efficiency where it needs to be. The Hungry Hippo fairing passed its tests, opening and closing in 1.5 seconds. Hardware's moving to the launch pad. By every traditional metric, Neutron's on track. But that's where things get complicated. Because Archimedes has never actually flown, 0 flight hours, and Rocket Lab's planning to bet everything on it working perfectly while also testing a radical new fairing design and attempting to land the booster. All on Flight 1. Look at what happened with Falcon 9. SpaceX had a huge advantage. Merlin engines already had dozens of flights on Falcon 1 before they ever put them on Falcon 9. Even with all that flight heritage, they still lost engines. CRS-1 in 2012 engine failed mid-flight. SpaceX survived because they'd built in redundancy and had years of data to work with. Rocket Lab doesn't have that cushion. They're going straight from test stand to orbital mission. Now the Hungry Hippo fairing, I'll admit, it's clever. Traditional fairings get jettisoned because keeping them costs you performance. Every kilogram of structure you keep is a kilogram you can't use for payload. SpaceX throws their fairings away. Well, they recover them now, but still separate them, because the math works out better that way. Rocket Lab's betting they can flip that equation. Maybe they can, but we won't know until it flies. Think about what this fairing has to do. It has to handle max Q, that's 275,000 pounds of aerodynamic force trying to rip it apart. Then it operates in vacuum, extreme temperature swings, opens up to deploy the payload, closes again, and becomes part of the landing vehicle. Those canards they tested to 125% load, sure, they passed static tests. But static testing doesn't tell you what happens when you've got plasma streaming around them during re-entry, and the flight computer's making thousands of tiny adjustments per second. Which brings us to landing. Rocket Lab caught an Electron with a helicopter once. Spectacular footage, really impressive engineering.